We continue now. We're now looking at what we call molecular mass. Please just remember that the mass of one atom is found on the periodic table. Whatever, if you want one atom of hydrogen, one atom of oxygen, one atom of chlorine, whatever, if you want the mass of one atom of that guy, is going to be found on your periodic table. And the units we use, atomic mass units, U. Okay? Why do we use that atomic mass unit? Because it makes work easy for us. So we can actually measure the mass of these atoms as long as we are using atomic mass units, and we can know how much what their mass is. Now, when we then look at the second one, which is going to be molecular mass, when we hear the word molecular, we don't panic. We don't, because molecular formula was for molecular compounds. Now, molecular mass is also for molecular compounds. So now we'll be dealing with molecular compounds, but instead of just knowing their formula only, after knowing their formula, we now want to know their mass. So their mass comes from, it is based on their chemical formula. If you want to know the mass of a molecular compound, you look at the molecular formula. And I'm going to jump a lot of the things. Let me just show you what the definition says. It says it's the total mass of a molecule. Okay, yes, it's the total mass of a molecule. It's the sum of the atomic masses of all the atoms that are present. You add the masses of all the atoms that are present in one molecule, and you're going to get the molecular mass. So it's very easy. We take one molecule, we put its formula down, because the molecule tells us the formula. We can just check our molecule and see what it has. And then when we put the formula down, we can be able to look at the mass, because we will say, what are the atoms that are there? How many of each? So we will say if there are 2 hydrogens, we'll put the 2 hydrogens, and then we'll put our oxygen, and we add their masses together. The answer we're going to get is going to be our molecular mass or molecular weight. So easy, right? So easy. So let's consider water. If we want to find the molecular mass of water, we look at its formula, H2O. So because of that, it is we're going to take hydrogen, which has an atomic mass of 1.0, blah, 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 and oxygen, which is an atomic mass of 1.59. To get the molecular mass, since there are 2 hydrogens, we'll say 2 times that of hydrogen. Then we have the 1 for oxygen. Then we add them together, and we are going to get the molecular mass, being 18.015 units. It is an atomic mass unit. We now have the molecular mass of water. So what is it based on? It's based on the chemical formula. When we say chemical formula, what chemical formula is that? The chemical formula of chemical compounds, of molecular compounds, is called the molecular formula. Molecular formula. Anyway, why do we use atomic mass units again? Because here, just like the atomic mass, it is expressed in atomic mass units because it just represents combined mass of a bunch of atoms within one molecule, just a few atoms. So we can't change from U, okay? Because we're just dealing with a few atoms. We're not dealing with a lot, okay? We are still dealing with just a few atoms, so we stick to atomic mass unit to keep our calculations easy, because we're still dealing with small guys. We only have, like, in water, we only had 3. Okay, we just added 3 atoms. Like, really? Do you think if we add, we'll get a big value that we can change to the other units like grams or kgs? No, we only have 3. So for the molecular formula, if you want to find the molecular mass, just add the masses of the guys in the molecular formula. Done. Done, done, done. Now we look at one more, which we then link to the final one. This one more is going to be the formula mass. I'm sure some of you can already guess. Formula mass will now be the mass of each formula unit. Okay, it's similar to molecular mass, but it is used for ionic compounds, not molecular compounds. Okay, it's used for ionic compounds, which don't, here's the idea. They don't form discrete molecules. Okay, ionic compounds are not separate, they are one. So when we want to find the mass, what are you doing? We'll find the mass of one formula unit. Okay, so the chemical formula is important. The chemical formula. What will be the chemical formula? When we say the chemical formula is important again, we saw that for molecular mass, the chemical formula was important. We had it as H2O, and we saw that we said 2 times the mass of hydrogen plus the mass of oxygen. So that's the same thing we have. On formula mass, the chemical is important as well. The formula, which formula? Formula unit. Okay, no longer molecular formula, but formula unit. Formula unit, we have NaCl. That is the formula unit. That is the formula unit. We can use it to know the formula mass. Sorry, the formula mass by knowing the formula unit, because we will just do the same thing we did to the molecular mass, but now we are doing it for these guys that are in a formula unit. So if we have magnesium chloride MgCl2, which we talked about, then what do we have? We first look at the masses of each. Magnesium is a mass of that, chlorine is a mass of that. But since in our magnesium chloride we will have 1 magnesium and 2 chlorines, we're going to add them like that, and we'll just get 95.21 atomic mass units. We still use atomic mass units because we are still dealing with a few atoms. In here, in the formula unit, we only had 3. 2 chlorines and 1 magnesium. So because we are still dealing with small things, to get the masses, we use atomic mass units. Then we will have the formula mass. Why do we use it here? That's what we are now showing here. Why do you use atomic mass units still? Because even though ionic compounds don't have molecules, we still use U as the unit because of the formula unit. Because here, why? We still use it because it's the smallest whole number ratio in the compound. Okay? It is, we don't have many atoms. We don't have many things in here. Now, remember that when you're looking at this, you say to me, but do you know that in MgCl2, we just write it as MgCl2, but the truth is we have an Mg2 plus, which is bonded to a Cl minus and another Cl minus. So you'll be saying, what makes us use chlorine, mass of chlorine, when it was actually a chlorine ion? Because when we are doing the transfer, we use the mass, we use Cl minus. Why? Why do we get the mass of Cl minus as the same as the mass of just Cl? Because to come from Cl to Cl minus, it came from receiving an electron, and an electron has negligible mass. Okay? So because of that, when an electron leaves, we still have magnesium being the same mass. So we just take. Okay, anyway, that is it. This is the other part which I want you to know, the formula mass. What is the formula mass? It is when you multiply or when you combine the masses of each of the ions present in your molecule and in your each of the ions present in your formula unit, and you're just going to add those masses and you'd be done. So it's important to know the formula unit. To say for magnesium chloride or sodium chloride, which is table salt, my NaCl is NaCl. So whatever it is, because now this will be the end of it if you know the formula mass, right? If you know the formula mass, you would have done a lot. Now in the next video, we'll do one more, which then links everything together, and you can now hit the road with questions as well. All right, bye for now.